Okay. Welcome back. Okay. Linear approximation. The idea is this. Very fancy word. Linear approximation. Okay. What does it actually use? Means linear line, right? Linear is a line. Linear is a studying of line. Okay. Just the word line in there. What is the better way to study a line without using tangent line? Okay. So tangent line. We use tangent line. Last time we used tangent line to take the derivative. We use tangent line to kind of like get the idea of velocity, right? It's use tangent line to find derivative. Tangent line to find limit. Bunch of idea about tangent line. Today we use tangent line to guess a value, guess a value of a function that is hard to find. Okay. What does it actually mean? For instance, square root of 2, I mean square root of 4 plus minus 2. Well, easy, everybody knows. What is square root of 3.98? Without using calculator. Okay, I heard a calculator. Okay. That is the idea, right there. You don't know. The correct answer is you don't really know. You can guess, right? You can approximate. Okay, square root of 4. 4 is greater than this. And square root of 4 is give you 2. Right? So square root of 4, square root of 3.98 give you something, 1 point something, right? That's the best you can guess, right? 1.9 something. That is the idea. Okay. But what exactly is that number? Or this number? 4.05. What exactly is this number? We don't know yet. That is why we're going to use this. Okay, linear approximation. That's actually what happened here. For example, 5 square. Yeah, 25. 6 square, 36. 8 square, 91, right? And so on. But this. If we add some more decimal, in other words, every number, we add a couple more decimal. We try to do the math with that decimal. It's a pain in the ass, literally, right? Oh, yeah. Right. Okay, so now we gonna develop a technique. So before we go back to these, we're gonna answer this question. We're gonna go back to these, but before that, we're gonna set up, develop why tangent line. What's the relation between tangent line and answer this? Okay. Okay, so set up. Let's say I want you to draw carefully. This one. You have a function. That is a little bit this. Maybe a parabola. Okay, a parabola. I can give. Okay. We go back to very basic drawing. Pick a point, P. Okay, that P is gonna have the coordinate A, right, for X. And if I use this one is f of X. Okay, if A is right here, and instead of calling this axis is Y axis, I call that is f of X. Then what would be the Y coordinate? F of A. Which is down here, right, f of A. Then again, the idea is tangent line. Draw a tangent line there. Tangent line T. Okay. In order, okay. We actually, I'm going to skip the detail in the middle. We actually know how to find tangent line, right? We developed that, right? Tangent line point slope formula, we know that, right? We know this function, parabola, right? We know how to find derivative. That would be the slope. We have the point. We use point slope. We able to find that tangent line, okay? You don't need to draw this, but I just want to zoom in. Okay, I put a box around that. If I zoom it in, okay, color, that's just this line. And that point P, okay, now bigger, P, okay, literally zoom in, right? P, A, F of A, F of A. The tangent line, that red line, and I'm gonna shrink that line. Just tiny like this. T, right? It's a line. It could be longer, it could be shorter. So that red line now just tiny over here. Okay. Right? If I shrink it enough, it becomes that point, right? Shrink it smaller, smaller, eventually that red one, smaller, 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 become that point. Right? So in other words, that tangent line can be used to approximate the coordinate, this coordinate, right? That coordinate, I'm assuming, A, F of A, the relation between this black one and the red one, they are very close to each other. The more I get smaller, this tangent line, the more shrink it down, eventually I can use this red line that I know how to find. Couple sections ago, I know how to find that red line. I know how to find this red line. I know how to find the smaller version of that red line, maybe around here. And using that red line, I can use that red line to tell me the coordinate of this black dot right there. Right? And that red line is a tangent line. Okay, that's the idea, huh? Now, specifically, the tangent line at P, A, F of A would be point-slope formula. Y minus, instead of using Y2 and X1, Y1, instead of using X1, Y1, now I'm going to plug in correctly, it's going to be F of A, right? Okay, the slope, X minus A, okay, over there. The slope right here, right? That is slope M, right? Right there, point slope. Instead of writing the traditional M, I'm using something more calculus. What do I write? F prime of A to be exactly. That is slope. Okay. Let's say Y and then back. I keep comparing, I keep recalling the tangent line. Here, when you have point slope, what do you do next? You're going to solve for Y, right? You're going to bring this one to the right-hand side, correct? Bring the one to the right-hand side, you have the equation of tangent line, Y equal mx plus b, correct? I'm going to do that, exactly the same thing. Y would be my tangent line, so I'm going to put Y down here. I'm going to plus f of A both sides. So bring this one to here. So Y equal f of A plus f prime of A x minus A. Okay, that is just YT above, right here. YT above right there. Write the equation. That line, the red line above there, is this one right here. At this point, A. Okay. So I'm specifically right here. Right here, I have this line. Generally, I want everywhere. I pick here, 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 everywhere, anywhere. So what do I change in this equation? If I want to find a tangent line here, 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 everywhere. Generally, what do I change? Any idea? Nope. Just the one on the left. If I want to generalize all of that, I just want to change the notation of the left-hand side. Actually, that would be the formula right here. I just want to change the notation on the left-hand side. And I use that to approximate this one in here. Okay. Instead of using the y of t, I use the notation of linear approximation, L of x. Okay. L for linear approximation. Down here. L of x, which is this, which is that one. It's called linear approximation. In fact, that is just equation of a tangent line. If you look at the right-hand side. Right-hand side, no more, no less than equation of a tangent line. Right? M, x minus x1, y1 right here. Right? But they're using different notation. And by using this notation, I am able to approximate this function. Approximate this function. Okay. Okay. So L of x, left-hand side is called linearization, linear approximation of f at a. Okay. And this is the only thing you need to memorize. Okay. Don't try to memorize by heart. Just think of that as an equation of a tangent line. There's a slope in there. There's a point in there. Point slope formula in there. Okay. Any questions so far? I'm going to apply this. Use this. Come back to our problems down here. There you go. Okay. Find linearization, right? Find linearization, in other words, phi L of x of this function at a. Okay. This problem literally has two parts, two sentences. Two parts. Part A. Phi linearization. Don't forget about this. Okay, forget about this. Phi linearization L of x of this function at a. Okay. Part B. Use this whatever you have over here, which is this. Use this one to approximate these two numbers. Okay. So linearization, the box above, the formula, whatever we develop above, that's going to be f of a, right, plus f prime of a, x minus a. Okay. Okay. So linearization or linear approximation as of x equal, okay, in this case, f of x is this. What would be f of a? Square root of a. Very simple. Plus f prime of a. 1 over 2 square root of a. Yes. There you go. X minus a. There you go. That's it. That part A. Done. In fact, this one is approximating of this. In other words, when you write like this, that is another way of saying this. That is literally mean this. Square root of x. Somehow, approximation, remember, approximate. This is the symbol, approximate, somehow equal this. Haha. Literally that. Look at the left-hand side and the right-hand side. Linear approximation give you that. Tangent line give you that. Do you think they're equal? Left-hand side, just square root of something. Equal whatever on the right-hand side. Okay. Tripping, right? You should be tripping here. You should be, curious here. How this somehow equal that? And it's true. You're gonna see right away. How do you apply that? How do you actually do that? Okay, we're gonna do 2 examples. Calculate this using that. Okay, so 1 by 1. Linearization done. Use L of x to approximate first one. Square root of 3.98. Okay. So 3.98. Okay. That basically asking you to do this. Remember that L of x is the left hand side. That is square root of x. Okay. F of x. L of 3.98. X in this case is this number. X is that number. X is that number. Okay. You approximate. So you use this symbol. Okay. I'm trying to approximate this number using linear approximation. Okay. Which number is that? This number. Okay. And which formula am I going to plug in? I just have that. Okay. I'm going to plug in that formula. But remember, there are 2 things for you to plug in. X and A. X is this number. I'm going to write there. 3.98 right there. Okay. You see how I placed it according to the position. Okay. X is that number, not A. That is the L of x. X is 3.98. Then how about A? So X and A. X is that 3.98. A. You remember you trying to approximate. You trying to approximate this number. Then A will be think about your anchor point. Some number that if you plug in, it gives you the answer right away. It's something that's familiar to you. This one not familiar. 3.98 not familiar. Square root of 3.98. For the love of God, you don't know this literally. Then A will be some anchor point, something that's familiar to you, something that when you plug in here, you get the answer. What do you think? 4. A is 4. So in this case, A, you pick 4. X is 3.98. Okay, I'm going to use a different color maybe. 4, 4, 4, and 4. Okay. So what does it mean? Square root of this somehow equal this. Now you have a bunch of numbers in here. Punch in calculator. How much is here? Remember, keep the positive. From here, you just need the positive. 2 plus 1 over 2 times square root of 4 is 1 over 4, right? 3.98 minus 4. Negative 0.02. Okay. Can somebody use a calculator? So 2 minus, right? 0.02 divided by 4, right? Minus times this, so minus here. 0.02 divided by 4, how much is that? (0.02) divided by 4. Huh? 0.01. How many 0? We have to be careful with the 0. So 1 0. Hold on. If that divided by 2, then 0.01. No, divided by 4. 0.005, right? Right? 2 minus 0.005. 1.995. In other words, square root of 3.98. Okay, this means square root of 3.98 approximately 1.995. Now, use your calculator. Put in square root of this. Square root of 3.98. How much is that? How much is that? Now give me the actual number. So actual value, true one from calculator, 3.98 equal 994, keep going.
993734.
Compare. We just off the decimal right here. Right here, right? And where does this come from? Where does that come from? It comes from that. Remember, I just asked you, do you think the left-hand side equal to the right-hand side? And now they actually equal. They really close, they're not equal. They really close to each other. But how is that? How does that work? Why? Okay, that's some question you should ask. Why? Using tangent line, something like really unrelated to this number. Tangent line have nothing to do with this number. Okay, there's no beef between them, right? How come tangent line can have you to calculate this with our calculator? Okay, approximate really close. Okay, think about that. Okay, can you try again? Now do again with 4.05. Try that. Go for Europe, try that. Approximate 4.05. Try that yourself. How much would that be? You're gonna have 2 point something, right? It's radar.
So just like we just choose 4 as the number, like just because it's close to what we think the answer is. Or?
Yes. You can choose 4. What's the next one you can choose?
I mean, like, so yeah, if it was like square root of like, you know.
Yeah. Square root of something that you can get the whole number. So the reason we choose 4 from here, because 4 is the closest one to this. That you know the answer. So the next thing the next number you can choose is, what do you think? 4, and next one will be 9. Square root of 9 is 3. Next one will be 16, 25, 64, and so on. But the further away, the further from this number, you're gonna have worse approximation, right? You're gonna have more decimal approximate, okay? You're gonna get further away from the actual number down here. You get really far away from this number, okay? So the best number is choose as close as possible to this number. However, also able to take square root, okay? A could be 9, could be 1, could be 16, could be 64, 25, right? 64, and so on. But however, it could doesn't mean it is a good one. You can use them. But the approximation, if you plug them in calculator, you're gonna have very off, okay, very off number. So this is bad choice, to be honest. The only one that's good here is the number 4. So in other words, when you do this problem, when you pick A, it has to come down to your intuition. You have to pick some number that you use your intuition. Which number should be the best to approximate this? Let's say, if I ask you to approximate that would be X, right? You pick A. $16, right? That's the way to go. You don't want to pick 25. You don't want to pick 4, right? You want to pick 16. Because you know square root of 16 is 4. Okay, so that's the idea. So what did you approximate to get you 4.05? Anyone? 4.05. So technically L of 4.05 is how much? Anyone? How much? No. If you do this, it's approximate. Yeah, this one. Do this process. 2.0125. So actually, let me squeeze in another one. Okay, maybe over here. So L of 4.05 equal 2.0125. And then when you use okay, so that is approximating. 4.05 equal how much? 2 point?
2.0124611.
Okay, and so on. See? One more time. Using the tension line, whatever happened over here, what kind of voodoo over here happened over here. Somehow, give you the answer. Approximate to this value. And that is calculus. That is a tool of calculus. Okay. Okay, now let's compare. Now we know the answer of both of them. The error, we want to know the error. Okay, usually when we approximate something, we want to learn the error in our calculation. That means the difference, right? The difference between the true value right here and the approximation, this, an absolute value, right? So that means how far away from those two approximations. Okay, so the error in this case, so the error for 3.98 case is the absolute value of the true value 1.9949, now maybe around 6 decimal is good, minus the approximation. Okay, so I'm going to use this, which is the yellow one. I'm going to subtract the approximation 1.995. Okay. The difference between them is how much? 0.00, how much? 4 minus 5. 199, right? The negative in the front. That is why. Okay, the absolute value for what? We just want the quantity. So the absolute value, this absolute value, to get rid of this minus. Somehow we're going to have negative, positive. Doesn't matter. We just want the quantity, the positive. So 0.00. Am I doing correct math? Is it? 199? Okay. So, how do you explain this number? Okay. These two numbers, you understand, right? Approximate give you that. True value calculator give you this. How do you explain this number? How do you explain this one? If you use a sentence, how do you explain it? Today 8. Group 8. Group 8. Okay. Group 8. In a full sentence. Okay, you know the name, right? Look at that. Group 8. So how do you kind of like, use English, just regular. What does it mean by this number? Where's the group 8? 8. Okay, go ahead. Okay, you write a report to your manager one day, working Apple, working for Microsoft. You have that report with that error. Manager asks you, what does that mean?
That's how much the value differs from the actual.
Keep going, keep going.
The actual value?
The difference between
The actual value and the approximated value?
the approximate value. Okay, so we come down to that number. Then what will be your conclusion? Usually when you have the result to answer, write report to anything, the final answer, your answer is very important. You explain what happened there, but your final answer is you have to give a comment. That's a good report. Was that a good quarter? Was that a good sale? Was that a bad sale? Was that a good calculation? Do we need to recalculate? Do we need to recalibrate the system? Do we need to model again? So now from your group 8, what do you think? Is that a good approximation? Is that a bad approximation? What do you think in terms of?
It's a good approximation because the values differ. The difference between the values is less than 1.
Yeah, that's considered. Yeah, that's how it's meant. Yeah, very good job. Okay. For us, that's good. For us, that's good. But actually, when you go out there in industry, that's very bad. Okay, just so you know. Now we talk reality. Okay, thank you for your explanation. For us, that's good. But in industry, when you calculate, when you build a machine, okay, the off number, it should be, the number 0 should be no less than 10 zeros. And then you can have number over here. That is a good calculation. The off number, the offset, you approximate your job as a data analysis or whatever the job, if you're working as a team, your number should be around there to be considered a good estimation, good model. Okay. Because one zero off costs a couple million for industry to build whatever that is. Okay. So around another 0 off, okay, whole team got demoted. Another 0 off, someone got fired. Right. So it's true. Okay. That's reality. Okay. So very good. Next. How about this? Previous example. You was given a function, find linearization. That basically the first step. The first step took you literally 2 lines. No, 1 line right here. That is like a description, right? Literally 1 line. Write this one down and use this one to approximate whatever the number they have. Okay. And in this problem, linearization, according to that, you have f of a. And you was given f of x right here, square root of x. Okay. The next example, you don't have f of x. You still have to write this one down first. Linearization is this. F of a, that is y1 plus the slope x minus x1, right? Poisson formula. In this case, there is no f of x given to you beside that number. So what do you think the function that represents this? X squared, right? Last example, you were talking about 3.98. You was discussing that, right? The original function that represents that is that. Then this x squared, correct? Then f of a squared. F prime of a, 2a, x minus a. There you go, you have that. Okay, that's the first step. You need to have that. Then use that to approximate 5.33. So in other words, 5.33 square is nothing more than L of 5.33. And that 5.33, you are replacing with the letter x. Then in that formula, you're going to replace exactly the x. Okay, so 5.33 minus. Okay, you see I leave a few blank over there. Okay. So this problem, you guess the function. You guess correctly. That's x squared. You have x 5.33. What would be a? 5, right? You can use 6 too. Yes. This one is you have more leeway. Because square of any number, you can know square of any whole integer. So a is 5. So I'm going to use maybe a different color. Yellow. A in this case, a is 5, 5, 5. Okay. Now, 25, 10, 5.33, 0.33, clearly. Okay. 25, 10 plus 0.33. 10 plus some decimal number. What do we do with the decimal number? I shift the decimal number, right? 3.3. 25 plus 3.3. 28.3. So in other words, 5.33 square is around 28.3. I really like this, the final step, this step right here. Use calculator. How much it is exactly? 5.33. 5.33 square.
28.4089.
28 point.
4089.
Okay, around there. See? Right. Remember, since we start this problem from here to here, we didn't use a calculator, right? All of this calculation we did. We didn't use a calculator. Somehow we're able to calculate square of this number is that, which is also very close to this. And this, thanks to linear approximation. And linear approximation is tangent line. There. How cool is that? Cool, right? Okay. Any question? So this section is easy, right? Isn't it easy? Okay. Yes.
At the bottom, we have 20.3. Shouldn't be 28.4 because of the exact, we have 28.4.
Oh, is that okay? Because it's very off. This approximation is heavily depend on that number. We pick 5, we get this. Okay. This one is never have to be exactly like this. If we get exactly like this, that is a wonderful job. We pick a good number. We pick 5 because we only able to know 5 square give me this. Okay. It varies. So in other words, it could be 3, it could be different number, depend on how much we pick here. We can use 6. Yeah, you can try 6, 36, plus 10 times, and so on. We're going to have much different than this. Okay. So that's a good question. It's approximate. So there is no fixed answer for that. Okay. There is no fixed answer for this one right here. It's approximate. Okay. All right. So let's okay. For the last 15 minutes, every group, now this activity here, every group try to approximate this. I'm not going to give you anything else more, any other information besides approximating. Approximating. Two point zero. No, 2.398 cube. There. Okay. Of course, you cannot know the value of that by just looking. You cannot know. So try to approximate that. use the best, you can use whatever we just learned. You cannot do that, right? 2.9398 times 2.398 times 3.398. Here. Okay. So each group, that's for your activity, that's for your attendance today, huh? So work in a group, turn in that paper. Work in a group. Just one piece of paper per group is enough. For your attendance today. Turn. Okay, we know. Lesson's over. You don't need to look at the ball anymore. Okay, look at your friends. No. School over. And then you can call it a day. When you finish, yep, you can call it a day.